right, ladies and gentlemen, this is your boy Hank Hackerson. We are in room 2 of the Linux privilege escalation module with TryHackMe. This room is a part of the shells and privilege escalation module, and that whole thing is about part of the beginner path of TryHackMe's education. So we're getting towards the end of the beginner path. There's a lot of stuff that was just read-only stuff that I didn't record, and we're mostly going to be doing the stuff that actually have labs associated with it. In the last video, we did the first part of Linux privilege escalation, and this is going to be the second part of Linux privilege escalation. If you don't have access to TryHackMe, definitely make sure that you get yourself a membership. It's pretty affordable and inexpensive, but if you want even more of a discount, there's a link in the description that gives you a credit towards your membership, and you can definitely take advantage of that so you can follow along with these labs, because they're way more fun when you follow along. And so you can always obviously do your own Linux installation and basically go through these exercises with your own Linux installation, but it would require that you have two different machines, because TryHackMe gives you this one machine right here that you're going to be hacking into. And then when I click the attack box, which is loading on the right side of the screen, can I zoom out of this and zoom into this? Okay, cool. That's nice to know. So the attack box is as it says, it's the attack box. It's the machine that we're going to be using to attack the other machine. So it technically gives you access to at least two machines at a time, which is very, very useful. So that's basically my whole spiel on TryHackMe. Make sure to like, subscribe, follow, share, do all that good shit, or good stuff. Excuse my French. And yeah, that's about it. So I'm just gonna read through this real quick, and then we'll kind of start the whole thing. This entire room is about practicality, and so from the very beginning, we're deploying the machine right here so that we can start hacking it and getting ourselves privilege escalation. And so for the people who don't know exactly what privilege escalation means, I'm just gonna show you this thing real quick, just so you can kind of see what it actually means, right? So this was from the first room. Can I zoom in here? There we go. So there's horizontal privilege escalation and there's vertical privilege escalation. Horizontal means you go from the first user to another user that has the same privileges or the same permissions. Vertical means you go from whatever these users are to a root or an admin privilege or permission level. And when you're an admin or a root, you get to do a bunch of things on the machine, like create your own users or get access to restricted information or so on and so forth. So there's a lot of stuff that admins can do that normal users cannot do. And the whole idea with privilege escalation is to go from whatever user to a root. And sometimes user 2 may have access to something that user 1 doesn't have access to. And whatever they have access to gives them an exploit or a vulnerability or a pathway to become an admin that this person didn't have access to. So that's kind of the idea here. And this is the great visual representation of what we're going to be trying to do for the rest of the labs that is on the more advanced room right there. So this is our room. The attack box is already up. So the first thing that we want to do, as it says, is you want to secure shell into the user so that we can start kind of messing around with it. So just to read, it's aimed at walking you through a variety of Linux privilege escalation techniques. To do this, you must first deploy an intentionally vulnerable Debian. This VM, which is the thing that we just launched when we did that, is created by Sagi Shahar as a part of a local privilege escalation workshop, but has been updated by Tiberius as a part of Linux privilege escalation for offensive security practitioners and beyond on Udemy. Full explanations of various techniques used in this room are available there, along with demos and tips for finding privilege escalations in Linux. We may be referring to this if we get stuck throughout the exercises, and make sure you're connected to the TryHackMe VPN if you're going to use your own Kali, or you can use the attack box. And so SSH is available on port 22. you can log into the user account with the following command, which is the basic SSH login command. And if you see the following message, if you want to continue, you want to say yes, obviously, and then we're going to put in the password for the user, and it should be fairly straightforward to get in. So here we go. We're going to open up our terminal. Let me see if I can. Okay, so I think this is how we're going to, yeah, there you go. Now we can actually zoom in. All right, so I could do it like that. So I'll just do this and I'll zoom in. And well, first let me get my let me get the IP address that we're supposed to log into. And so it's user at IP, and then the password is password 321. Okay, so basically SSH, too many S's, SSH user at, and then IP address, enter, yes, password 321. Just like that. And look, we are here, user at Debian, and we're already in the system. Cool. So if you get the error saying such and such, this is because OpenSSH has deprecated, and add this at the end of the SSH to your command to connect, which we did not get that error, and we're already logged in, right? So who am I? I am user, and host name is Debian, right? LS, and we get to see the OVPN and a tools folder. And if we went to tools, we're inside tools, and we have all these different tools in here. So we are in the system. The next task will walk you through different privilege escalation techniques. After each technique, you should have a root shell. Remember to exit out of the shell and or reestablish a session as the user account before starting the next one. Okay, cool. So boom, we're done with this. Run the ID command. What is the result? So we're just going to do ID. And this is the result. Very long result. And we're just going to copy this result. Whoa. And go here. Enter. And that's the result. Very good. Okay. First part, easy enough. And this is a long one, by the way, you guys. I'm going to try to edit as much of the stuff out so it becomes a short video. But this is a big room, and there's a lot of stuff to do. And I have my tea here because I already had a cup of coffee today. So I already have my tea, and I'm ready to go. I am committed. I am going to finish this room in one sitting, and it's going to be pretty epic. So let's do it. Okay, cool. Here we go. Service exploits. My SQL service is running as root, and the root user for the service does not have a password assigned. We can use a popular exploit that takes advantage of user-defined functions, UDFs, to run system commands as root via the MySQL service. Change into the folder right here, and then cd, which is this command basically, compile the Raptor C exploit code. So .c means it's a C plus or a C code file using the following commands. So we're going to do the compiler, and then we're going to do that file, and then shared soname Raptor you got to do all these things. And then after these two are done, you're going to connect to MySQL as the root user and execute the following command on the MySQL shell to create a user-defined function do system using the compiled exploit, which is going to be these series of commands right here. And then use the function to copy bin bash to temp root bash and set the SUID permission, etc. Exiting out of MySQL shell, run the temp, etc. And remember to remove the temp root bash executable. Okay, so we're gonna do all of these things and make sure that we can actually pull it off. And so to kind of make this a little bit easier, I'm gonna create another window on this screen. So actually have all of these things in one window, and that way I can zoom in here, right? Like that. Very good. And actually run the commands. Okay, so let's go to home user tools my SQL UDF, and we're already here. So what's inside here? That's the Raptor C file. So GCC for general compile, and we're going to run these two commands, Raptor UDF, oops, F, there you go. So, and by the way, so if you already know the name of a file and you want to just, instead of having to type the entire file, you want to just kind of make sure that you get the file quickly. You can press tab in most shell sessions, and as long as you have the first portion of the file, it usually just completes it for you. So since there's only one file in here, if I just do wrap and press tab, it'll do the whole thing. And so there you go, we have that. And then fpic, like that. Press enter. Okay, so that seems to have worked. Now let's do the second set of code here. So oops, so name Raptor. Can I click that? No, now I can't do that. So Raptor udf2.so. Oh, that's because it's a different file. So let's just make sure I spelled that right. Raptor underscore udf2.so. Very good. O, and then Raptor underscore udf2.so, and Raptor underscore udf2.o, and lc. Press that. Okay. So far so good, I think. So MySQL u root. Ha! It worked. Who am I? Who am I? I guess I'm root. Print working directory. I can't really see anything. To create a user-defined function do system using our compiled exploit. So, oh, I see. MySQL doesn't give you a who am I command. Duh. Let's see if ls works. ls doesn't work either. But it seems like it's actually worked and we're in here. So, since we're already in the MySQL, we're going to do use MySQL. So I'm going to copy the whole series. Oh, interesting. Okay, so I'm going to zoom out real quick. That's how you move around the screen when it's already zoomed. We're going to copy this whole thing. We're going to come here and paste the whole thing. One row affected, create function. Okay, and then that's the last line, so press enter. Okay, I think it worked. Let's see. Select do system cp bin bash tmp root bash chmod plus xs tmp root bash and enter. Okay, it seems like it did actually work. So if you've never done anything like this before, this is kind of going over your head, so I totally understand. And we just want to make sure that whatever the lab is telling us to do, we actually do correctly to get the desired result. But the first series of commands that I copy pasted in there, it basically said use MySQL, and then the next line was create table, and then the couple of words after that were the actual name of the table, and then the third line said insert into foo, because that was the name of the table, the values of whatever is inside the file raptor udf.so, which is the thing that we just created with the first couple of commands that we ran. And then the fourth line was select everything from foo into dump file, and then it gave and if you can just you can go back to the portion where I was reading through the instructions, so, and then you could see the commands. And so for the next section, I'll spend a little bit more time explaining the commands instead of having to do it when it's off screen. But oh, it's literally right here. Oh my gosh. Okay, so use MySQL, create a table called foo, insert into foo the values that are inside this file, and then select everything. The asterisk stands for everything, so select everything from the foo table and into dump file, meaning dump it into the dump file, and then this is going to be the name of the dump file basically. And then create function, so create a function called do system and return integer, so name raptor2 etc. Okay, so that's basically these series of commands. And then when we ran that, select do system, because we just created the function, and then copy bin bash yada yada. So copy bin bash into the temp folder root bash, and that's basically a bash instance or the bash file. And then chmod means change the permissions, so change modification. I think that's technically what it stands for. Correct me if I'm wrong, correct me in the comments. And then, so this is basically the command in Linux to give permissions or change permissions on any kind of file. And you want to add, so when you do a plus, that means you're adding. When you do a minus, you're taking away. So you want to add the permissions X for execute and S for super ID, which is SUID. And then you want to add those two into the new file that we just created, right? So we copied the original bash file into our temp bash file. And now we want to change the permissions of our temp bash file into execute and super UID. And then so that's done. So we did that, and that was the last thing that we just did right here. And so it says now exit out of the MySQL shell, type exit or /quit and press enter, and then run the temp root bash executable with P to gain a shell running with root privileges. So basically that's what we're supposed to do right now. So we're just going to do that real quick. So we're going to exit, and we're out of SQL. It said bye. And then we're going to go to execute any kind of a bash file. You just want to do this. You do a dot and then the / tmp root bash. That should actually run it. And if I do p, okay, fine. So cd tmp ls root bash p. There you go. It ran. Who am I? I am root. Very good. So it worked. And let's see. The last one is remove the temporary file and exit. That's basically what it wants us to do. So I think I could do it while I'm already here, right? So remove root bash ls. It's no longer inside this thing, and exit. And that's it. And we're back to the user named user. So there you go. That was the first portion of this thing. So read the following commands and do it, and we did, and it's completed. So that was basic service exploits that we just ran. So let's go to the next one. Weak file permissions, the readable etc shadow file. So the etc shadow file contains user password hashes and is usually readable only by the root user. Note that the etc shadow file is on the VM is world readable. So the one that we're on right now is world readable, meaning that anybody could read it. So when you do ls and then list that file, it's going to give you what the permissions of that file are. View the contents of the etc shadow file. So cat reads whatever the text file is, or nano file, anything like that. So cat will read that file for us. Each line of the file represents a user, which we discussed in the previous room, so I'm not going to go too deep into that. And so what it wants us to do is it wants us to save the user's hash to a file called hash.txt on your Kali VM, which is our attack box, and then use John the Ripper. And we did a really crazy room on John the Ripper, so it's a really, really awesome thing. To crack it, you may have to unzip the word list rocku.txt gz first and run the command using sudo depending on your version of Kali. I think we already have rocku.txt inside our machine, so I don't think we need to unzip anything. And then switch to the root user after you have cracked the hash to get his password by using su for switch user root, and then it's going to ask us for the password. And then so on the root user's password, what is the root user's password hash? That's going to be the first thing that we're going to get. What hashing algorithm was used to produce the root user's password hash? We'll try to find that as well. There's a Python file that's really useful that allows us to do that. And then what is the root user's password? So these are the questions that we have to answer inside of this thing. So I'm already here. So I'm going to create a separate one because we're going to run John to unlock the hash text or the hash file. So cd, and then we're going to go to lsl etc shadow. Let me zoom in here so you could see what I'm doing here. So lsl etc shadow, it's going to give us the permission. So it says read write for the creator, which is root, and then read for the group, and then read write. Ooh, it seems to be that we can even write to this file, as anybody who can view it, so everybody else. So that's what it means: the creator's permissions, the group's permissions, and then the actual everybody else permissions. So that's the file. So let's read it. So I want to just do nano because I feel, well, maybe I could just do cat and actually read it. etc shadow. There you go. So that's it. And this is the very first entry is always the root user. So let's make sure that that's actually the thing. And it kind of looks like it was cut off at the end. So let me just make sure that it is actually, that is the information. Yeah, so it is, no, it is the full thing. Okay, cool, fine. So we copied that. So now we're going to go into our own, this is the attack box shell. And so here we're just going to do nano, and we're going to do hash.txt, and we're going to save the root user's hash in here, just like that. So you do Control O to write, and you want to do enter, yes. So it wrote one line, and we could do Control X to exit. So it's done. So now we're going to run John, whoops, which is this command right here. So John word list user da 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 da. We're going to run that to actually get our answer, right? So word list equals, what was it? It's user share word lists rocku.txt and then hash.txt. Oh, you know what? I think it's this thing. That's why. I knew it looked like it was cut off at the end because this is the full root. Okay, so that is what I did wrong. There we go. That's the full. So we're gonna go here. I had to get hash ID anyway, but we're gonna go back into here. Actually, an easier way to do this is we're just gonna remove hash.txt. Then we're gonna create a new hash.txt and paste the full thing in here. That seems like much more correct. And so let me just run John, see if it'll actually give us the answer. Yeah, it worked this time because we actually had the proper hash. And so there you go, password 123. Let's see if in here it gives us, yeah, there you go, detect hash type SHA-512 crypt. So we already even had that. So okay, so what is the hash? Is SHA-512 crypt. That's right. And the password is password 123. And that's right too. So maybe we want to just take this portion. We'll do that. We'll just take that portion, copy. That might be the issue. Yeah, that's the issue. Okay, fair enough. Fine. So you know what? I incorrectly did it because to use John the Ripper, you need the whole thing. But the actual password hash is right after the username when you have colons between, and this is kind of where I skipped the reading of the instructions because I just assumed. So anything between colons is a different item inside this entire thing. So this is kind of easier to see. So that's the root user. The hash is not visible. This is, I think, their group ID. This is also not visible. And then so these things are blocked off, and it's easier to actually see it inside the password file to see what all of these things stand for. But between each colon, just so you know, between each colon is a separate item inside this whole thing, and the hash is the second item. And so it just happens to be that we can see the hash for the root user, and that is what allows us to hack into this machine, so on and so forth. So yeah, that's basically it, and that's what the answer for this was. I was typing in the whole thing when I was supposed to just type in the hash, and we did it. So we're here. So let's now switch to the root user. So we're gonna go su root password 123, and we are now root. And am I supposed to do anything while I'm here? Nope, because it said that was it. All right, so there you go. All right, so the next one, weak file permissions. the writable etc shadow. So we already noticed from the last exercise that we ran that it actually had a read and write permission for everybody. So a file contains user password hashes that are usually readable by the root user. Note that the shadow file on the VM is world writable, meaning everybody could write on it. And when we ran this command, we already saw that. So generate a new password hash with a password of your choice, which is going to be make password msha12, and that's going to be the new password here, and we'll just do whatever. And then edit the etc shadow file and replace the original root user's password hash with the one that you just generated. Then switch to the root user using the new password. Simple enough. Okay. And I didn't even need to do the whole thing with the with hash ID, but at least now you know what that is. Zoom out. Very good. So let's exit. And since we're now user again, let me zoom back in here. Okay, so we are going to, just for reference, ls etc shadow, and it shows us that these are the last permissions that everybody has. So it's read and write, so we can actually write to that. So if that's the case, let's make a password hash for SHA512, and we'll do new password is going to be the password. Press enter, and this is our full hash, and it needs to be SHA512 because that's the format that the original thing is. So now I can go to nano etc shadow and actually go up here, zoom up a little bit, and replace the entirety of this thing. Ooh, this is gonna be, how am I supposed to delete the whole thing? Can I just go here and delete? Ooh, I deleted the colon too, so I gotta make sure I remember to put in the colon. And we're gonna delete all the way to the 17, 9, the 17. Oof. Let's hope that this actually works. Otherwise, we're gonna be in trouble. It did work. So we were able to paste in our, oh no, what did I do? I think I only added one character to it. Yeah, I did. Okay, so SU root new password. Okay, it worked. Very good. All right, it worked. Okay, cool. Boom. That worked too. Moving along. Weak file permissions, the writable etc password file, and up until now we've been working on the etc shadow file. So now the etc password file, as you'll see, contains information about user accounts. It is world readable, but usually only writable by the root user. Historically, the etc password file contains user password hashes, and in some versions of Linux will still allow password hashes to be stored here, but it wasn't like that in our, oh, maybe it might be, we'll see. The etc password file is world writable, as we'll see in a minute. Generate a new password hash with a password of your choice for OpenSSL, password, new password here, and then edit the etc password file and place the generated password hash between the first and second colon of the root user, replacing the X. And if that's the case, you should be able to switch to the root user with that new password. Alternatively, you can just copy the user's row and append it to the bottom of the file, changing the first instance of the word root to new root and placing the generated password hash between the first and second colon. So we could either create a new one, or we could create, or we could just replace the old one. So run the ID command as the new root user. What is the result? So I guess we should just create a new root user instead of the old one, because we actually need the response for this. So if that is indeed the case, we are going to do exactly that. All right, so we're going to exit. And Now we're going to do lsl, the etc password file, just so we can see what's over here. And you can see that it is also read and write permission for the world, for everybody else other than the group and the actual root user. So we're going to create a new password hash. What are we doing? We're going to go nano etc password, and we're just going to copy this whole thing. Copy, come to the bottom of the file, and we're going to paste it. Or I'm going to do first new, then I'm going to paste it. And so that's going to be new root. And then we're just going to go right in the middle right here. And we're going to take this thing and we're going to paste it in between those two colons. There we go. X. Yes, save it. Press enter. I feel really silly right now because I used the password hash instead of the actual password. There you go. Who am I? New root ID. I think this should be it. There you go. That worked. And move on to the next one. Okay, here we go. Sudo shell escape sequences. So sudo L is basically all of the things that sudo can do, right? So that command gives you all the things that sudo can do. GTFO, I think, stands for get the fuck out, but I'm not sure. So list the programs which sudo allows your user to run. Or yeah, you know what? I should say that better. So on whatever user you're on, if you do sudo L, it tells you what commands that you can do with sudo as your current user, right? And then so visit this thing and search for some of the program names. If the program is listed with sudo as a function, you can use it to elevate privileges, usually via an escape sequence. Choose a program from the list and try to gain a root shell using the instructions from GTFO bins. For an extra challenge, try to gain a root shell using all the programs on the list. In the interest of time, I'm not going to do that. I'm going to do whatever is required to get these questions answered, and then we're going to move on to the next task. So for an extra challenge, try to do all the ones. Remember to exit out of the root shell before continuing. Okay, great. How many programs is user allowed to run via sudo? And it's multiple because we can see it's 2 digits. One program on the list doesn't have a shell escape sequence on GTFO bins. Which is it? Okay. Consider how you might use this program with sudo to gain root privileges without a shell escape sequence. Okay. Consider how you might use this program with sudo to gain root privileges without a shell escape sequence. Okay. What does that say for us? Play around with certain options that the program has. Okay. So again, in the interest of time, I'm probably not going to do this last one right here, but we are going to see how many actual programs our user has permission to. Okay, so it's sudo L gives us all the programs that our user can run, and that's basically what it says. User, so the user may run the following commands on this host, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11. One program on the list doesn't have a shell escape sequence on GTFO bins. So let's actually open up GTFO bins on a different link so you can also see what that looks like. So this is a really useful website that basically shows you what all the different functions connected to these binaries are, and if you can actually run them, which is basically these different things, right? So if we can run all of these as root with no password required, that means we could probably do some crazy things on here. So it says which one program on the list doesn't have a shell escape sequence on GTFO bins. Which is it? Okay, so I'm gonna have to go through all of these, and I'm gonna do it on a different window. There's Apache 2 CTL, but there's no Apache 2, so that might be the answer, and more of course is on there. So I think that is the answer. So let's see, Apache 2. Okay, that's the answer. So it says, let's see, choose a program from the list to try to gain a root shell using the instructions from GTF opens. So let's try to see if we can do nano. Let's see what we can do with nano. Okay, so let's see if top. We'll see the very first one, see what that does on the GTFO website. Let's see what it got for us. If top. And to get a shell, we just gotta get this command right here. So I guess I'm just gonna do sudo, sudo, and then paste, enter. Oh, that worked. Okay, simple enough. That's basically what it was. Sudo if top. The full thing was basically if top and then exclamation / bin / sh, which you already saw as we did that. And now we are root. So we're already in the root. We got the root access using a sudo command. Our sudo environment variables can be configured. Sudo can be configured to inherit certain environment variables from user's environment. Check which environment variables are inherited. Look for env keep options. Env keep options. So is it the same? I think it is the same, right? Because it told us to exit out of the root shell before continuing. So same thing. So I guess sudo l ld preload and the ld library path are both inherited from the user's environment. LD preload loads a shared object before any others when a program is run. LD library path provides a list of directories when shared libraries are searched for. Create a shared object using the code located at that file by just doing the compiler for C, and then run one of the programs you're allowed to run via sudo listed when running sudo l, while setting the LD preload environment variable to the full path of the new shared project. And then a root shell should spawn. Exit out of the shell before continuing. Depending on the program you choose, you may need to exit out of this as well. Run LDD against the Apache 2 program to file to see which shared libraries are used by the program. Okay. Create a shared object with the same name as one of the listed libraries using the code located at that. So basically, it's telling us what to do with Apache from the last task. Located at home, which is another GCC compiler command, and then run Apache using sudo, using the library path that we just created. A root shell should spawn. Exit out of the shell. Try renaming tmtlibcrypt to the name of another library to use Apache 2 and rerun Apache 2 with sudo again. Did it work? If not, try to figure out why not and how the library path code could be changed to make it work. Remember to exit out of the root shell before continuing. So we don't have to answer anything, but let's just try these exercises and see how it all works, right? So first is telling us to do sudo l to see what is available. It's here. Oh, I feel very silly. This right here is what we're supposed to be looking for. So, and env keep options is what it was referring to. LD preload is what we need to see that it actually exists on here, and it also has LD library path as well. So that means that these are the commands that we can mess with. So since that is indeed the case, we're going to do the command that's listed here. I'm just going to copy and paste it, and that's the compiler command, and we got that. So since we can do find with one of these things, so we're just going to run the actual command. There we go, sudo ld underscore preload, and we're going to do tmp preload.so, and we're going to use find, which is one of the commands that we could do. And lo and behold, who am I? I am root. Nice. So it worked. Let's see if we can do it with another one, which is the Apache 2. So let's exit out of root. Wow, it exited the whole thing. Very good. And we are now the user again. Okay, so since we exited out of the root, let's use the second command that it gave us, which is this thing right here. Actually, I'm sorry. First, LDD against Apache to see which shared libraries are used by the program. So LDD user sbin Apache 2. So here we go. LDD user sbin Apache 2. And these are the libraries that is available right here. So these are all the names of the libraries that are available for Apache 2. So we're going to use one of these library names to try to gain an Apache 2 shell from this thing, right? So this is creating a duplicate library, and then we're going to run the sudo command with the Apache 2 library, and this should give us the root. There we go. We got the root like that. I mean, it already says it as the username, but it's just like running who am I as a good practice. Root shell should spawn, exit out of the shell. Let's try renaming to the name of another library used by Apache 2 and rerun Apache 2 using sudo again. Did it work? If not, try to figure out why not and how the library path C code could be changed to make it work. So it did work, and in the interest of time, I am not going to run through all of these different ones. Okay, moving on. Cron tabs, file permissions. Cron jobs are programs or scripts which users can schedule to run at specific times or intervals. Cron table files or cron tabs store the configuration for cron jobs. So it's basically scheduled tasks, right? The system-wide location for these tasks are at etc cron tab. So view the contents using that. There should be 2 cron jobs scheduled to run every minute, and one runs that shell file, which is override. The other runs compress shell file. So locate the full path of the override shell file by running locate, and it gives us the path. And then note that the file is world writable. So if we run the lsl command, it'll tell us which permissions it has. And then so if we rewrite the contents of this thing with running a basic bash shell, and after changing the IP address to that of your Kali Linux box, so our attack box, we're going to change this IP address to, and then this is going to be the port, I'm guessing. And then so once we've done that, we do a netcat listener on the attack box on the same exact port, and it says every 2 minutes, or every minute. It runs every minute. So within a minute, we should actually get a root shell on our attack box, right? So let's run it. Let's run it and see how that works. So we're going to exit out of our previous root. And so just to see what the jobs in cron tab are, we're going to run cat, and then it shows us, right? So it says minute, hour, date of month, month itself, date of the week, the user that can run it, and what the command is, right? So it says minute 17, I guess. Or no, I'm sorry, these are the IDs. So excuse me. So the ID number, and then the minute, hour, etc., etc. So the one that runs every 1 minute seems to be, let's see if we kind of increase that a little bit. It's these two right here. It's the ones that are down here. So okay, it's a little bit easier to read. And so anyways, it doesn't really matter. What's important is that these are the 2 files that they're talking about, so override and compress sh. And so we're going to try to find overwrite.sh to see where the actual file is. And locate warning, it is located at user local bin overwrite sh. So very good. So if we just do user local bin overwrite.sh, we'll see the permissions right here. And it says read write as the entire person, or the world writable, right? It's world writable, as they like to say. So if that's the case, what we're going to do is we're going to replace the contents of that file with this little script. So which is nano user local bin overwrite.sh. I'm going to open this little thing, which is this very basic thing right here. And so we're just going to delete that, and we're going to replace it with our little bash command which is this. Wait, that, and then dev TCP p1010. What is the attack box? 1010 63 46 1010 63 46 at port 4444, and then we're going to do 0 and 1. That's basically the, let me just double check and make sure. Yep, and that's it. So write it, enter, exit. So if I did that command one more time, just to double check and make sure, if we just ran that command one more time, we did actually change the file. Very good. So now, since it's going to run every minute and it's going to give us a shell on our attack box, all we need to do is just go to the attack box on this port and give it a minute. And just like that, look at that, we got the connection from the virtual machine and we are root, as it says. Look at that. So cool. Done and done. Cron jobs, the path environment variable. So same thing, we can see where the cron tab files are, and then there's one in there that starts with home user, which is our user's home directory. Create a file called override.sh in your home directory with the following contents. Which is copy bash into a temporary file called root bash, change the command or change the permissions, to executable SUID, and make sure that the file is executable. And so we just got to make sure that this file as well as this file both are executable. Wait for the cron job to run, which as we found out, it runs every minute. And once it runs, then run the temp root bash command with p to gain a shell with root privileges. Remember to remove the modified code, remove the tmp root bash executable, and exit out of the elevated shell before continuing, as you will create this file again later in the room. Okay, so since that is indeed the case, we're going to run exactly what it tells us to do. So here we go. We're here, and we're going to, cat cron tab is literally right here, so I don't need to run that again, because that's exactly what we ran over here to see what cron tabs we got. Where is it? Cat, there you go. Cat cron tab gave us our actual cron tabs, and this is what we were looking for originally, which is path home user. So we have that. So it says that we want to create a file called override.sh in our home directory with the following contents. So let's go to home user, and we're here, and there's basically a couple of files in there, but we're inside our home folder. And so now we want to create one called override.sh inside this section, and it's going to have the shebang line at the end, which calls bash, saying that this is actual bash file. And what we're doing basically is cp bin bash to the temp folder called root bash, and then we're going to change the permissions of it to executable super tmp root bash. That's basically all we're doing here. Okay, cool. And then now we just need to change the permissions of the actual override.sh file to executable, and then wait for the cron job to run. Should not take longer than a minute. Then run tmp root bash command with yada yada yada. So if I just go from here to the temp folder, because that's where we're creating the root bash file, right? So we're going to give it a couple of minutes or a minute, and we're going to check to make sure that the actual root bash file is created. And once it's been created, we can run our overwrite.sh file. There we go. That's our root bash file. So we're going to go back to home user. So we're going to run tmp root bash with a p permission. That gives us root. There you go. Okay. So since that is indeed the case, remember to remove the modified code, remove the root bash executable, and exit out of the elevated shell before continuing, as you will create this file later on. So remove tmp root bash. Would that work? I think that probably worked, I think. And exit. And we've exited. Let's see, cd tmp ls. Yep, it's not in here. Very good. And we're done with this. Whoops. What is the value of the path variable in etc cron tab? This is the value of the path variable. Cool. Cron jobs wildcards. View the contents of the other cron job script, which is compress sh. Note that the tar command is being run with a wildcard in your home directory. Take a look at the get the fuck out bins page for tar. Note that tar has command line options that let you run other commands as part of a checkpoint feature. Use MSF Venom on your Kali box to create a reverse shell ALF binary. Update the lhost IP address accordingly, obviously, to our IP. Transfer the shell ELF file to home user on the Debian VM. You can use SCP or host the file on a web server using Python and then wget on our other machine to get it. And then create these two files in the home user file. And then when the tar command in the cron job runs, the wildcard will expand to include these two files. Since their file names are valid, tar command line options, tar will recognize them as such and treat them as command line options rather than file names. Set up a netcat listener on the Kali box and wait for the cron job to run. Should not take longer than a minute. A root shell should connect back to the netcat listener. Remember to exit and delete all these files you created to prevent the cron job from executing again. Okay, great. So, from the top, what are we going to do from the top? First and foremost, we are going to see what's inside this file. So it says cd, go to the home of the user and just do a tar command and basically run this backup thing with a wildcard looking for anything that looks like this, right? Okay, fair enough. So this is the GTFO bins, and so if we just look for tar, it's right here, and it gives us basically all the things that can be done, right? So note that tar command has tar has command line options that let you run other commands as a part of a checkpoint feature, which is this thing. And so use MSF Venom on your Kali box to generate a reverse shell ELF binary and update the host accordingly. Transfer the shell ELF file to your home. Create those two files in the home folder of the user. And then when the tar command in the cron job runs, the wildcard will expand to include these files. Since their file names are valid tar command line options, tar will recognize them as such. Okay, should be, we'll see. We'll see if this is all we got to do over here. All right, so here we go. First and foremost, we need to go to our attack box, which is this thing, and run MSF Venom with the payload for Linux x64 shell reverse TCP. And what we're going to do is change the L host, which is our listening host, to our attack box IP, which is 10.10.63.46, and L port is going to be what port? Doesn't matter. Doesn't matter. So 4444, and elf o shell.elf. So output is going to be our little elf file. And once that completes, we're going to transfer it to our machine right here using Python. And then, yeah, just run the rest of the command. So should be relatively simple. There's our file completed. Shell.elf, there we go. Python 3 HTTP server on port 8888. And we have our server running. So now we're going to go here, and it is 10.10.63.46. So here we go. wget from HTTP 10.10.63.46 on port 1234. We are going to get the file, what is it called? Shell.elf. I think that was what the problem was. I was in the wrong directory. So let me see if I can get it now. I believe that was the issue. Yeah, I was in the wrong directory. Okay, great. So now we have the shell.elf file. So if we do lsl shell.elf, it says that we have no executable permissions. So chmod +x shell.elf lsl shell.elf. Now we do have executable permissions on it. Great. And so now while we're inside the home directory, home user directory, we're going to create these checkpoint equals 1. And then we're going to create another one. Equals, or excuse me, checkpoint action equals execute shell.elf. Okay, so there's that. So now it says when the tar command in the cron job runs, the wildcard will expand to include these files that we just created. Since their names, since the file names are valid tar command line options, tar will recognize them as such and treat them as the command line. So okay, so we're gonna go back to here while that's happening. And we're going to exit this, and we're just going to do a netcat listener. And let us see if this actually works. And we should be on 444. Yeah, that is the actual port. And I mean, if everything goes according to plan, the thing should actually run and give us a shell as root. Cool, and we just got the connection. Who am I? I am root. I am Groot. Cool, so there we go. And so just remember to exit out of the root shell. Great, we can do that. While we're here, actually, we might as well do remove home user shell.elf. Remove home user checkpoint equals 1. And remove home user checkpoint action equals execute shell.elf. Okay, and let's exit out of that, and let's ls here, and we don't have any of those files, so should be fine, should be good. And we can click complete. Okay, here we go. The next piece right here. So find all the SUID executables on this machine using this command. Note that user spim xm appears in the results. Try to find a known exploit for this on exploitdb. Google and or GitHub are good places to search. And in a local privilege escalation exploit matching this version of xm exactly should be available. A copy can be found on the VM over here. So run the exploit script to gain a root shell. So, I mean, it seems like all we really have to do this is that. Let's just make sure that that is indeed the case though, right? So here we go. All right, so the first command to run, whoa, a little bit too much of a zoom. The first command to run is this command. So we're gonna run this command. Oops. Ugh. Paste. Cool. And there it is. And it said to pay attention for which one? The one that has XM 4.3. And so it says that we should be able to find something called this thing right here. So this should already exist on our machine. So if that's the case, if I do the locate command, it's right there. So that is indeed the case. Home user cd tools ls. There is nothing in here called SUID, duh, SUID ls. There we go, XM ls, and there's our file. So cde, run it, and we got root. Nice. I am root, exit, and there is that. Okay. All right, moving on. So SUID, SGID, shared object injection. So there is this thing inside this thing is vulnerable to shared object injection. First, execute the file and note that currently it displays a progress bar before exiting. Run strace or strace on the file and search the output for open access calls and for no such file errors. So strace on this thing, and to make sure that we don't get any errors, then we're searching for that. Then note that the executable tries to load the shared object within our home directory, but it can't be found. So create the config directory for this thing that is trying to load for us. And by making this, the example shared object code can be found at home user tools SUID simply spawns a bash shell. Compile the code into a shared object at the location that we need it to be, which is going to be inside that config location right here. And then execute the executable again, and note that this time instead of a progress bar we get a root shell. Okay, cool. So fair enough. So here we go. Let's go from the top and run the exact list of commands here. So we got first, if we run this user local bin SUID SO, we get a little progress bar. Okay, so if we just first run strace user local bin SUID so and 2 and 1, excuse me, and then grep open access no such file, open access, okay, open, and so there's several over here, and the very last one right here is the one that they're talking about, that it says there is no such file or directory. So trying to open this, and we got no such file or directory. Okay, so then what we're gonna do while we're in our home user directory, we're going to make the directory make dir home user dot config. All right, so we made our directory dot config, and it's right there. Very good. Okay, so example shared object code can be found at the okay, very good. So we're going to use our compiler, and we're going to create this home user dot config libcalc.so. Very good. And it's going to calc.c. Okay, that should be fine. Now let's try to run it again. And now we got a root shell. Very good. SUID environment variables. So the SUID environment executable can be exploited due to its inheriting the user's path environment variable and attempting to execute programs without specifying an absolute path. First, we're going to execute this thing. Then we're going to run strings on that thing again to get all of the printable characters. And then one line says this thing. Service Apache to start suggests that the service executable is being called correct to start the web server. However, the full path of the executable is not being used. Okay, so compile the code located at that into an executable called service. The code simply spawns a bash shell. Prepend the current directory or where the new service executable is located to the path variable and run the SUID by doing this. So path equals the new path variable with what we just created. So we should get a root shell, right? So let's try that out. Environment variables, and come on, what's going on? There we go. So we're gonna go here and we're gonna run it. So user local bin SUID in environment, and it says starting Apache, and it's already running, but it didn't use the full file path, right? So bin SUID env, oh, strings, excuse me, user local bin SUID env. There we go. These are all of the strings inside this mofo, and at the end of it, it gives us the last line, right? And so it says that the full path is not being used. So what we're going to do is we're going to take advantage of that. So we're going to use the GCC, the compiler for C, and we're going to create an output called service home user tools SUID service.compile, service.c, excuse me. And then we're going to prepend it to our path variable, and it's going to be user local bin SUID env, and that should be fine. And we are now a root. Very good, just like that, completed. Nicely done. SUID SGID executables abusing shell features number 1. So the environment 2 executable is identical to the first one, except that it uses the absolute path of the executable to start the Apache 2 web server. So we're going to verify it with the strings command. And then in bash versions less than this is going to, it's possible to define shell functions with names that resemble file paths, then export those functions so that they are used instead of any actual executable at file path. Verify the version of bash installed on Debian VM is less than that. So we're going to make sure that our version is less than this version, and then create a bash function with the name user bin service that executes a bash shell. Using P permissions are preserved, okay, and export the function. And then so you're going to create the function with this command, we're going to export it with that command, and then we're going to run it again to get a root shell. And that should be how the whole thing, this should be how the whole thing works, how the cookie crumbles, as they say. So we're going to verify first and foremost that user local bin suid env2 actually uses the full path, which it does. So what we're going to do is we're going to first verify that bin bash version is less than 4.2, which it actually is. Very good. So then in that case, what we're going to do is we're going to create a function with the p command. That's our function, and we're going to export the function. Okay. And now, if we just run the suid env2 again, we should get a root. Oh, I was already root. Oh, I need to exit. Oh, dang. I mean, I did all of that as root, so I wonder if... Oh wait, user local bin suid env2. User local bin suid env2. It's already running. So, okay, let me see. Let's do that all over again because I forgot to exit out of root. And I got a bunch of different root shells. Okay, so there's that. Bin bash version is less than 4.2. So let's create a function called user sbin service bin bash with the p command. And we're going to export that function to user sbin service, and now we're going to run local bin suid env2. Okay, and it worked. Who am I? Great. Remember to exit root. Gotta always remember to exit root. All right, cool. Moving on. We are definitely more than halfway there. So abusing shell features part 2. This will not work on bash 4.4 and above. When in debugging mode, bash uses the environment variable ps4 to display an extra prompt for debugging statements. Run this executable with bash debugging enabled and the ps4 variable set to an embedded command which creates an suid version of bin bash. So I think this is the full command right here. And then run the temp root bash executable with p to gain a shell with root privileges. And got to make sure that our expiration doesn't actually happen. And then remember to remove the tmp root bash executable and exit out of the elevated shell before continuing and create this, because we're going to create it again. Okay, so how do I add time to this? We added some time to that, and we're going to add some time to our attack box as well. And now we're going to run the commands that we are being told to run. And so I got the full command here. So let me zoom in here and see if I could just paste it, run it. Okay. Excuse me. And so when we run that with debugging, and we see, I mean, these are all the notices that we get from debugging, right? When you run it with debugging enabled, the PS4 variable set to an embedded command, which we already set that variable, and the embedded command was this whole thing, right? So where's the, just to kind of show you the full thing, where is it? Right here. So the PS4 variable has been set to this whole thing. That's that entire command is what we're running with this one variable, right? So when we do that, then the next time that we do root bash p, we get root. Look at that. And so remember to remove root bash. Very good. And exit. Always remember to exit root, kids, when you're running these. And I keep like double zooming in. Okay, cool. So here we go. Passwords and keys, history files. If a user accidentally types their password on the command line instead of into a password prompt, it may get recorded in a history file. View the contents of all hidden history files in the user's home directory. And then note that the user has tried to connect to a MySQL server at some point using the root username and a password submitted via the command line. Note that there is no space between the P option and the password, meaning that that was actually the password. So as soon as you press enter, you put in the password. So switch to the root user using the password that it gave us. And then what is the full MySQL command that the user executed? So we got to make sure that we also get that for our answer. So first and foremost, let's zoom out and then let's zoom back in over here to be able to see what's going on. So we're going to do cat history and less. I don't know why. Oh, I see. So notice that it said, there we go, right? So it said it ran the MySQL command, some host local root, so u root, user root, and p password 123. So that's our actual password. So what is it says what is the full MySQL command that's been executed, which is this thing. So we got to copy that, come here, paste it, get our correct answer. And should we actually do it? Yeah, su root with that password. So let's get out of here. Okay, quit is the word. So su root password 123. Maybe it's our new password that we made a while ago. Yeah, I changed the password earlier. I remember. That was the issue. Okay. All right, well, whatever. It didn't tell us that. See? See? It didn't tell us that. Okay, moving right along. Passwords and keys config files. Config files often contain passwords in plain text or other reversible formats. So we're going to go to the contents of our home, user home, user home. Note the presence of this OVPN file that we noticed at the very beginning, which is still there. So we're going to look at the contents. The file should contain a reference to another location where the root user's credentials can be found. Switch to the root user using the credentials, which is probably the new ones that we made anyway. And so what file did you find the root user's credentials in? So we got to make sure we find that as well. Okay, so here we go. It is so cold out here, you guys, while I'm recording this. I don't know what the temperature is. Let's see, actually. Let's real quick find the temperature, because it is chilly. And this is for Los Angeles. So for Los Angeles, this is very chilly. And it is 49 degrees outside. LS home user. Look at our OVPN file at the very beginning. So what's inside this file? myvpn.ovpn. Inside that, there is, looks like, let's see. Which file did you find the user's credentials in? I believe this is it, because that's really the only directory that's here anyways. So let's see if that is actually the case. And that is the correct answer. So let's see if we can actually, so cat etc open vpn auth.txt user password, but see, that's not it because we changed it. So it's gonna give us a wrong password. Yep. So we changed it to new password earlier in the room, and so now we got it. So it would have worked if we hadn't changed the password way earlier, which is important to note. Okay, moving on. Passwords and keys, SSH keys. All right, so sometimes users make backups of important files but fail to secure them with the correct permissions. Look for hidden files and directories in the system root, and we're going to look for the hidden files and directories. Note that there appears to be a hidden directory called .ssh, and this is always the case, or more often than not, this is the case. So we're going to look at the directory and see what's inside there. Note that there is a world readable file called root key. Further inspection of this file should indicate that it's a private SSH key. The name of the file suggests it is for the root user. Copy the key over to your Kali box. It's easier to just view the contents of the root key and copy paste the key. Fair enough. And give it the correct permissions, chmod 600 root key, otherwise your SSH client will refuse to use it. Use the key to log in to the Debian VM as root account. Note that due to the age of the box, some additional settings are required when using SSH. So this is going to be our entire command, it seems. And remember to exit out of the root shell before continuing. Okay. And that is actually the IP address that is at the end over here. Okay, so here we go. All right. We're getting on the home stretch, you guys. So lsla home, and then it's going to show us that there's a .ssh folder right there. And then so we're going to now do lsl/.ssh, and instead of that, there's a root key. Okay, so there's a root key in here. cd.ssh. Very good. ls again. Root key, nano root key. There is the entire key. All right, there we go. That's fine. So now, just gotta make sure I got the whole thing. Bro, stop messing with me. Copy. Okay. So now we're gonna go into thing right here and cover to your Kali box, copy paste the key, give it the correct permissions, otherwise your SSH client. Do we have a SSH thing in here? We do. So we're gonna go to cd SSH in here, and in here we're gonna do nano root key, and we're going to paste the entire thing in here. The chmod. I forgot to do that part. Okay, so I changed the permissions now. So let's do the last command and run it. There we go. Got the permissions. We are now root. Remember to exit. That is always so important. That is always so important. So important. And we have completed that. Okay, here we go. Third from the last. Files created via the network file system inherit the remote user's ID. If the user is root and root squashing is enabled, the ID will instead be set to nobody. So check the NFS share configuration on the Debian VM, and note that the temp share has root squashing disabled. So on your Kali box, switch to your root user if you are not already running as root, and then using Kali's root user, create a mount point on the Kali box and mount the TMP share. Update the IP accordingly. Then, still using Kali's root user, generate a payload using MSF Venom and save it to the mounted share folder. And this payload simply calls bin bash, so creates a shell. Still using Kali's root user, make the file executable and set the SUID super user permission, and then back on the Debian as the low privileged user, execute the file to gain a root shell. So let's run that. So let's first and foremost, and I'm going to make this a little bit smaller now, just to make our screen a little bit more accessible. Okay, so here we go. Cat etc exports. Cat. Let's go back. Oi. Cat etc exports. Okay, so there it is. Let's see what it says here. Note that the TMP share root squashing is disabled. So where's the TMP folder? Right here. And it says no root squash right there. Very good. Okay, so if that's the case, on the Kali box, which is this guy, we are going to go and switch to root user. I'm already on root user, so that's fine. Are we in the home directory? I believe we are. So make a directory in our temp folder called NFS for network file share. Then we're going to mount read write version equals 3, and we're going to mount with the attack box 1010 6346. 1010 6346 TMP, that's where it is. TMP NFS, that's where we're going to mount. Because NFS is not supported. What did I do wrong? Okay, we just did the sudo su just to make sure. Let's see if that helps. 6346 TMP NFS. It still says requested NFS version or transport protocol is not supported. That's kind of annoying. I guess I have the NFS folder though. So cd Alright, we're just gonna assume that that worked and run the rest of the commands to see if it actually did work. And hopefully it did work. Equals quote bin bash, not vin bash, bin bash with a p f elf o tmp nfs shell.elf. Alright, so that seems to have worked, and now we're just going to make sure that we give it the proper permissions so we don't get stuck again. Alright, so now in this machine we're going to just run. I think it's because we had a version issue with our MSF console, or excuse me, with our mount. I think that was the issue that we had. So the question that we need to answer though, it says, what is the name of the option that disables root squashing? If somebody can find out whether or not that was the reason why this did not work for us, I would very much appreciate it. Please leave that in the comments. In the interest of time, I'm not going to record that, but I will do the research myself to try to find that out, because that's actually very annoying. This was like the only thing that's literally the only thing that I can think of that it didn't work. Because the MSF Venom payload Linux 86 execute cmd bin bash with p-f elf o tmp nfs shell elf. Yeah, I mean, that's literally the only reason what I can think of that it didn't work. What is the name of the option that disables root squashing? This is the thing that was right here, so we have it. Where is it? Where is it? Where is it? Okay, let's run it again just to find it. Root squashing is done using cat etc exports. So this is the command that says no root squash. Boom. That's it. All right. Really annoyed by that. So if somebody can find out, I would sincerely appreciate it. Share in the comments. Let us know. Let us know. Kernel exploits can leave the system in an unstable state, which is why you should only run them as a last resort. So run the exploit suggester 2 tool for Linux to identify potential kernel exploits on the current system by using this command right here. And then the popular Linux kernel exploit Dirty Cow should be listed. Oh, this is a fun one. Exploit code for Dirty Cow can be found at this thing. And I'm guessing this is all on the Debian machine. It replaces the SUID file user bin password with one that spawns a shell as a backup of user bin password is made at tmp back. Compile the code using the gcc compile, and then once the exploit completes, run the password to gain a root shell. Remember to restore the original password file and exit the root shell before continuing. Okay. Alright, so first we're going to take the Perl command to identify potential exploits. Here we go. Paste. And so here we go, potential exploits. And in here, there's supposed to be Dirty Cow. Where's Dirty Cow? There it is. You dirty, dirty cow. Okay, so that's where it is. So now we're going to compile it using that command. Cannot open the output file cow, permission denied. That's annoying. Exploit code for Dirty Cow can be found at this cowc. It replaces the SUID with one that spawns a shell backup. Compile the code and run it. Note that it may take several minutes to complete. So maybe I'm supposed to, well, that's the run for it. So this is supposed to be the compiler, and it says I can't do it because I have no permissions. That is obnoxious. So let's see, lsl this thing. I need to see what the permissions are. Okay, so let's see, maybe we can do update to this, hopefully. Okay, so if that's the case, now it has, okay, so maybe now I can do it. Cannot open output file cow, permission denied. Why can't you open the output file cow? You are so annoying. I'm so annoyed. This is a second issue now that we're running into. Okay, so based on the research that I have done, this command right here should have actually worked, and it should have compiled the output file for cow for us, and then we should be able to run it and do all the things that we wanted to do. But unfortunately it didn't work, and it literally should exactly do what it says that it's going to do. So once you find the kernel exploit here, you compile the code using this command and it will compile it. So it's basically doesn't say any kind of response on the screen, it just doesn't give you an error. And then you run it with this, and then when you run that, I'll just show you what it looks like here. I don't know if you heard that. That was a YouTube tutorial for Python. So when you run that, it's supposed to look like this. So So that's the compile, and then that actually runs it. And this is dirty cow, and this is basically it: root privilege escalation, backing up, yada yada yada, and that's it. And from here, you can actually use user bin password, and it gives us root access at the bottom right there, and that's it. It's like it shouldn't be what happened. We should actually have gotten a result from that, but it didn't give us the result. But because I need this completion button, I'm going to press that, because we did the work and we did the research, just to confirm that we have done the research. And that's it. This is it. We just finished the room. This was the longest video that I have done so far. It's probably going to be excess of 2 hours, which is gnarly. I cannot believe that I fucking sat here and did this whole work. This was insane. I've sat in front of TryHackMe for hours before, but not in one module. This was kind of crazy. Especially as an introductory module too. This was insane. Anyways, as you can see, TryHackMe offers a lot of things, and you can do a lot of things. So definitely make sure that you get yourself a membership if you don't have one. There's a link with a discount or a credit or something that you can get. That's in the description. The membership is already very affordable, but if you get that link, then you also get a credit towards it. And make sure that you like, subscribe, share, comment, especially for the one that we couldn't find, the kernel exploit and the NFS task. If you find any answers to that, please make sure that you comment and turn on that notification bell so that you get notified the next time that a video comes out. And yeah, this is Hank Hackerson. It was fun hanging out with you. I hope you found some use from this room, and I will see you in the next video. Peace.